What is a differential equation? An equation involving differential coefficients or coefficients is called a differential equation. An equation involving differential coefficient or coefficients is called a differential equation. For example, is a differential equation because it has two differential coefficients. Now we will talk about order of differential equation. So the order of the highest differential coefficient in a differential equation is called the order of the differential equation. I repeat, the order of the highest differential coefficient in a differential equation is called order of the differential equation. For example, this is a differential equation in which three differential coefficients are used. This is first order differential coefficient, this is second order differential coefficient, and this is third order differential coefficient. So this is the highest differential coefficient present in this equation. So its order is 3. So order of this differential equation is 3 because the highest order differential coefficient is third differential coefficient in this. So order is equal to 3. Y double dash plus 2xy dash plus y is equal to 0. This is second example, and we have used different notions in this equation, and you might have aware of these notions because in 12th standard these are also used. d2y upon dx square may also be written as y double dash, and dy upon dx may also be written as y dash. Also we may write it as y2 and this y dash as y1. So different notions are used for differential coefficients. So y double dash, as you know well, that is d2y upon dx square. So order of this differential coefficient is 2 and order of this differential coefficient is 1. So there are two differential coefficients, but the highest order differential coefficient is the second order differential coefficient. So the order of this differential equation is equal to 2. Now we will talk about degree of a differential equation. The power of the highest differential coefficient in a differential equation is called the degree of the differential equation, provided all the powers of differential coefficients positive integers and the differential equation must be in a polynomial form. I repeat, the power of the highest differential coefficient in a differential equation is called degree of the differential equation, provided all the powers of the differential coefficients are positive integers. That means there should not be any negative integer as power of any differential coefficient or a fraction, and the differential equation must be in a polynomial form. That is, if any differential coefficient is given in trigonometric form or exponential form or logarithmic form, its degree is not defined. If any differential coefficient in a differential equation is written in some non-algebraic form, its degree is not defined. This is very important, so you must note it down. Now I will give you an example. This is a differential equation and its highest differential coefficient is d2y upon dx square. So we have to observe its whole power. So obviously its whole power is 1. d2y upon dx square is a second order differential coefficient and its power is 1. So order of this differential equation is 2, but degree is 1. Now if dy over dx whole square plus 2y is equal to x. This is a differential equation in which only one differential coefficient is there. So the highest differential coefficient, we may say the first order differential coefficient is the highest order differential coefficient in this equation and its power is 2. So here order is 1, but its whole power is 2. So degree of the differential equation is 2. Now I would like to give some more examples to make it more clear. Third example is d4y over dx to the power 4 plus sine d3y over dx cube is equal to 0. So if we talk about the highest differential coefficient in this equation, that is fourth order differential coefficient, so its order is 4. But if we talk about degree of differential equation, so as I told you, degree of the differential equation is not defined if any differential coefficient is given in some non-algebraic form, that is in trigonometric form or algebraic logarithmic form or exponential form. As you see, one differential coefficient is given in trigonometric form, that means in the angle of sine, so its degree is not defined. Let's take one more example. Say this is a differential equation d2y upon dx square whole square plus cos dy upon dx is equal to 0. So the highest differential coefficient used in this differential equation is d2y upon dx square. Its order is second order. So order of the differential equation is 2. But the degree, as I told you, the degree of a differential equation is the degree, the power of highest differential coefficient, which is 2 here. So don't commit any mistake to write the degree as 2 in this. Be very conscious, because one differential coefficient is given as the angle of cos. That means one differential coefficient is given in non-algebraic form. So again, by that rule, degree of this differential equation is not defined. So let's take one more example. Suppose this is a differential equation y triple dash whole square plus y double dash whole cube plus y dash whole raised to the power 4 plus y raised to the power 5 is equal to 0, and we need to find out the order and degree of this differential equation. So the highest differential coefficient is y triple dash and its order is 3. So order of the whole differential equation is 3. Now let's talk about degree of this differential equation. As I told you, the power of the highest differential coefficient is called degree of the differential equation. So highest differential coefficient is y triple dash and its power is 2. So degree is 2. Don't be confused about these powers. We don't have to take them under consideration, because by the definition the power of the highest differential coefficient is called degree of differential equation. So whether it is 3 or 300 or 3000, it doesn't matter. The degree of highest differential coefficient is 2, so degree of the differential equation is also 2. Now the sixth example is d2y upon dx square whole raised to the power 3 upon 2 is equal to y dy upon dx plus y. Though the differential equation is given in algebraic form but not in the polynomial form, because one of the power of the differential coefficient is given as a fraction. So first we have to make it positive integer. So for that we have to square both sides of this equation to eliminate this fraction. So it implies that squaring both sides we have d2y upon dx square whole cube is equal to y dy upon dx plus y whole square. Now all the powers are integral. So now we may find order and degree of the differential equation. So order of this differential equation is 2, because highest differential coefficient used in this differential equation is second order differential coefficient. So order of the differential equation is also 2, and degree is the power of the highest differential coefficient, which is 3 over there. So degree of the differential equation is 3.